Good morning, Tritons, or good afternoon, depending on when you're watching this video. Um, Obviously, I'm Mr. Galarza, and I just wanted to give you a simple tutorial on how to use the Gizmo element builder simulation so that it can help you with how to lay out the Bohr model project. So for the Bohr model project, you will be using the element builder Gizmo to help you create what we believe the atom looks like for these 18 elements. You will take screenshots, and more importantly, you will also align those screenshots just like the periodic table to make it look something like this, except you will have the drawings. Okay. The gizmo or the screenshots will look something like this. It will include the visual representation or the model of what we think the atom looks like. It lists how many protons, neutrons, electrons it has, and it should have the symbol and the element name, which is in this case boron, because it's element number 5. So let me show you how to get started. There is going to be this video linked. Glad you found it. And also this handout that walks you step by step on how to do this. Okay, so again, your goal is to do or to make all 18 of the first 18 elements on the periodic table. The Bohr models, that's what we believe the atom looks like for each of these elements. And hopefully you'll then start seeing another similarity of why elements are grouped into a family. Okay, so this is a handout here that is there just in case you get stuck. So let's get started with this. I included the link, the hyperlink for how to get to Gizmo, but let's say you don't have it. Just type in Gizmo, Gizmo, and it should come up. It should be one of the first things. And you are going to need to log in. You already should have your login account. And go to your correct class period. It won't matter which one I select here. This is my screen. Your screen is very specific. It'll only say what period you're logged into. So mine is a little different because it has all the classes I can access. So yours might actually launch immediately. I have to have an extra click, but this is the main screen. So in this screen, it allows you to develop the models, the animations of the first 18 elements. It doesn't let you go beyond. It's a kind of a bummer because it'd be kind of cool for you just for fun, just to be able to make, let's say, element 50 or element 118 to really see how much more enormous it is. But at least it gives us something, and it saves you from having to hand draw these, okay? Because a while ago, just a few years ago, everybody would have to hand draw these things. So what you will do is the first thing is over here on the right-hand side, you should select the first 3 boxes. Okay, the last box, if you want to, is totally optional. I think it doesn't really offer you that much information. It only tells you the location of the element on the periodic table and some very brief characteristics about it. So I don't think it's that helpful. That's one downfall to this. I wish it would give you more specifics about it. So please select these first 3 check boxes. This other checkbox right here, it says element notation. This is going more into high school. It's up to you, but I'm not going to select it. I don't want to confuse that. So right now it's set up to try to make hydrogen. It always, when you reset this thing, it always starts out with hydrogen as the first element. But let's go beyond. Let's say I wanted to do, lithium. So what you would do is the number at the top, that tells you how many protons. That's the first thing you would want to do. So lithium has 3 protons. Na, which is sodium, has 11 protons. Mg, which is 12, has 12 protons, etc. So the number at the top tells you how many number of protons to start with. These numbers up here tell you the group number. So you will be doing groups 1, group 2, group 13, 14, 15, 16, 17, and 18. You are skipping all of these down here because you are just doing elements 1 through 18. You do not need to worry about these. Besides, it doesn't allow us to make those with the gizmo. Okay, so again, I'm going to go ahead and start with element 3 just to avoid the simpler one. So I'm going to do number 3. So what I would do is start out with this first one. So I'm doing element 3, so that means I need 3 protons, okay? So right off the bat, oops, sorry, I clicked on 4. Tells you right here. I wanted 3. So 3 is lithium. 4 would be beryllium, okay? So I said I was going to do element 3, so let's go with that. And then notice it says the word radioactive. We're going to keep clicking the number of neutrons and electrons until this top heading up here says stable and nothing else. You don't want it to say ionized. You don't want it to say not valid, and you don't want it to say radioactive. We want a stable form of what lithium would be. So I will then click the neutrons, and I keep clicking it until there's the word stable comes up. But I still need to get rid of this word ionized. And how you're going to get rid of that word ionized is by clicking on the electrons, and you keep clicking until it stops. So this is the most common form of lithium. And now I would take a screenshot. Now, this does allow you to take a screenshot. The thing is it will take the screenshot of the whole thing, but if you want the whole thing, that's fine. You could use that and then copy and paste this image into a document. So you will want to have a document. I would use a Google Slides to do this. Again, my goal is to set up my screenshots just like this periodic table. So I'm going to open up a Google Slide. I should have had that going ahead of time, but I jumped the gun here. And I'm going to just start with a blank. Now because of these screenshots, they're kind of wide and big, I'm going to rotate the paper vertically like most of us would write. So you would do that by going up to the File menu and to the word Page Setup. And instead of widescreen, no, that's not what I want. I'm going to go right up here to print settings, it must be. No, okay. So I'm glad I'm doing this because I'm finding out what does work and what doesn't. So let me go again, open up a document, and let me rotate the paper. So it has to be under Page Setup. And instead of widescreen, I'll go here to custom, and I'm going to type in 8.5 by 11. That's the traditional size of a regular sheet of paper. So I'll type in 8.5 by 11. All right. So now here is my document. All right. And so I have this one here. Now what I will do is I'm going to paste that image I have there. Okay. So I'm going to paste this. So I'm going to copy the image. I'm just going to paste it right in here. There it is. Now I can make this one smaller because again, my goal is I need to put another element up here because what I'm trying to do is I'm going to lay it out with hydrogen on the top and Na right below it. And this is going to be group 1. So let me write that there. I'm going to write this as group 1. Okay. And so I can size this a little smaller. That works. And so in this empty spot is where I would put hydrogen, and below it be Na, which is sodium. So let me go back to the element builder and make sodium. Just so we're clear about sodium, sodium has 11 protons. So that's going to be a bigger element that I'm going to make with this creator. So that's what I'm going to do now. So I need to get the protons to 11. And so I'm going to raise that to 11. And there's 11 protons, and you can already see the symbol for Na. But you can see it says not valid. I need to get it to be stable. Not valid means it's not possible for sodium to have that setup. These are all radioactive. I don't want radioactive. I want a stable form of it. And there's the word stable. Now, I know you noticed, you assume that it would have 11 neutrons to 11 protons. The number of neutrons and protons is not always the same, okay? But the number of electrons will be the same. So again, what you need to do is make sure the word stable comes up, not radioactive, stable. And once that happens, you stop selecting the neutrons, and then we'll go to the electrons. And you want this ionized word to go away. And the only thing left up here at the top is stable. So I'm going to keep clicking on this until the ionized word, oh, it went away. There it is right there. So the stable form of sodium has 11 protons, 11 electrons, and 12 neutrons. Okay. We're eventually going to start going into why this has this situation and not equal amount. It turns out a lot of elements don't have the same number of neutrons as protons. So this is showing you what Na is. And notice it's a much larger atom. The nucleus is bigger on sodium, and notice the greater number of electrons. Okay. Notice how the electrons are put in a specific area. You've got one little electron out here just, by itself, and you've got some electrons kind of on a specific track, and then 2 electrons in the middle. That's not by accident. That's what really the periodic table predicts how the electrons are organized. So I'll take a screenshot, and there's my screenshot, and I'm going to just copy and paste this. I'm going to copy it. And this is sodium. So just to reiterate, sodium is below lithium. So I'm going to paste it right in my document right here below lithium. So let me paste it. And no, I don't want it up there. I want it down here. Okay, because the periodic table is hydrogen, then lithium, and then sodium. Let me just color that a little bit to make it stand out. You don't have to. I'm just going to make it stand out a little bit. And that's what group 1 would look like. Because of space, you're probably going to have to make 8 slides, 1 slide for each group. I just don't think it's going to fit trying to get, I know in a perfect world, we wish we could squeeze everything on 1 sheet of paper. You're just going to end up making it too hard to see. And the whole point is for people to be able to use this for information, including yourself. You might want to use this on a test or a quiz sometime. Okay. So I hope that helps. Obviously, if you run into a snag, in case you forgot, you just hit this plus sign to make the extra slides. Please do it in order. So if the first slide's group 1, the second slide should be group 2. Okay, just keep going in order. Group 1, group 2, group 13. It's not group 3. It's group 13, 14, 15, 16, 17, and 18. Okay, so I really hope this helped. And more importantly, if you've watched this video and it still didn't make sense, reach out and let me know.